Hello there, whoever watching. In this video, we'll talk about how to prepare for university interviews on mathematics. So, what is the purpose of a university interview? Well, firstly, it will tell us if you are ready for university mathematics. As you may expect, you must be comfortable with your A-level content, and moreover, we also want to know extra math content that would help smoothen the transition from A-level to university mathematics. 2, we also are interested if you can communicate your thought process. For example, are you able to articulate what you're thinking as well as what you're stuck on? And finally, are we comfortable with challenges and difficulties? One of the best predictors of university success is not intelligence, but actually the ability to organize and to work diligently. Now, in this video, we will show 3 questions, as well as some of the hints, solutions, and most importantly, discussions about the type of strategies and type of related questions that you may encounter. I will note that this is a YouTube video, and unfortunately, this is not the best platform nor the best medium to practice interview. Therefore, I recommend you to, of course, practice with your friends or your teachers or anyone around you to have a real-life discussion. So, here are 3 questions. First, a classic is to sketch the graph y equals x to the x. Curve sketching is a very popular question and is something that we want to be comfortable with. 2, a more mathematical proof type of question. Is an irrational to the power of irrational always irrational? You may need some time to understand what the statement is asking for. And third, find the limit of the sequence of the following. Again, it would be advisable to think about what limit of a sequence means. So, here's some hints for this graph sketching question. Firstly, what kind of function are we dealing with? Is it a polynomial or more like an exponential? And how can we rewrite this function? Once we rewrite this function, it will make it much easier to differentiate and hence find the critical point and then sketch the graph. 2, let's find the limit of this function when x approaches 0. And if we are unsure, it's okay to Google the limit, and we will discuss the type of trick and strategies we use to find limits. For question 2, the only hint I can really provide here is to first understand the question and then think about what we can try. Again, we'll discuss a lot more about this when we do the solution and the discussion section. And last but not least, question 3 was about finding the limit of the sequence. Now here, there are a lot of things to consider. For example, what does the limit of a sequence actually mean? For example, can we write some kind of recurrence relation so that it's much more easier to see what the sequence is? And finally, and more interestingly, how may we rigorously prove this limit? So, there are 3 ideas that will help us sketch this function. The first is to rewrite our function using exponential. The reason why it's more like an exponential is because our exponent here is not a constant, and therefore it is not a polynomial. Second, the limit of this exponent here happens to be 0 when x approaches 0. And therefore, this function, as x approaches 0, will converge to e to the 0, which is equal to 1. So we know the limit of the function when x approaches 0. Finally, we can work out the derivative using that representation. And from here, we see that the critical point when x is equal to e to the minus 1. So let's use these three facts to draw this function. The second result showed us that as x approaches 0, our function would approach 1. Now, because this function behaves like an exponential, as x gets large, y will also get large. So it looks something like this here. Finally, the derivative tells us that there are one stationary point at e to the minus 1. There are no more stationary points, as this function here will always be bigger than 0. Now, we may need to use some second derivative test to see if this is a minimum or a maximum. But this is actually not necessary by thinking about this intuitively. Let's say that we did have a maximum. Then, at e to the minus 1, we may have something that looks like this. However, as you see, there are two stationary points, one here and one here, which contradict the fact that there are only one stationary point. Therefore, it must be a minimum, and hence the graph will look something like this. Great. Now, I could imagine when you're watching the video, it looks very easy, but actually there's a lot of detail that's going on. And so let's talk about some of the general tips when it comes to graph sketching. For example, understanding what the domain and the range is, the type of x and y values the function can take, as well as having some idea where the roots and the intercept might be. We also want to work out the derivative and the limits, as those will give us the stationary points and certain points that are difficult to determine. And last but not least, there are some other interesting properties of the graph, for example, symmetry and asymptotes. The more you practice this, the more better you will become. Now, regarding the limit, how can we show that this limit is equal to 0? One way to do this is to use what's called the squeeze theorem. And if you've never seen this, I advise you to have a quick Google. But what it's about is we establish an inequality of the function we are interested in. And as we might see, as x gets closer to 0, this inequality will always be true, but this middle function is getting squeezed by the value 0 and 0 as x approaches 0. And therefore, the limit must also be 0. Again, if you've never seen this argument, I advise to have a quick Google because there are plenty of resources around. Finally, here's another classic trick, which is called the L'Hopital's rule. And this is where you use this trick when we have what's known as an indeterminate form by rewriting the function as ln x over 1 over x. Again, there are many videos online and elsewhere, so I would advise you to have a check. So, the next question is about proving or disproving whether irrational to the power of irrational is always irrational. For example, is root 2 to the power of root 2 irrational? Well, whenever we are trying to prove something that we are not sure of, it's usually easy to try to construct the simplest counterexample first. And in this example, there is actually such example, which is e to the power of ln 2. Now, of course, we're assuming that we know that e and ln2 is irrational, and we will talk about that later. Before that, let's talk about the following argument. Suppose that root 2 to the power of root 2 is irrational, then this to the power of root 2, which is a rational number, simplifies to 2, which is rational. Therefore, irrational to the power of irrational can be rational. The question is whether this is a valid proof. Is there anything to add to this proof? And also, what can we conclude about the irrationality of this number? Pause and have a think. So, let's go through the argument again, but this time more clearly. We assume that root 2 to the power of root 2 is irrational, because if this was rational, then we've already found a counterexample. The same argument still continues, where we said if this is irrational, then irrational to the power of irrational here becomes 2, which is irrational. Now, what's very interesting about this question is that we do not know if this number is irrational or not. Now, what's interesting is actually proving irrationality is actually a very difficult task. For example, we would expect this number to be irrational, but to prove it, we require a famous theorem called the Gelfand-Schneider theorem. And this theorem is quite tricky to prove, as it requires some deep theorems in complex numbers. And what's interesting, there are many theorems, such as the fundamental theorem of algebra, that requires the knowledge in complex numbers, such as the maximum modulus principle. Second, let's go back to the previous question about whether e and ln2 is irrational. I will put the proof that e is irrational on the description, but let's see if we can show ln2 is irrational fairly easily. Well, we're going to use proof by contradiction here, and when we do the algebra, we get 2 to the b is equal to e to the a, where a and b is an integer. Well, you would expect this right side to never be an integer, whether this would be an integer. But how do we know that? Well, one thing that you may want to look at is the fact that e is a very special number. Not only is it irrational, but it's what's known as a transcendental number. And hopefully, this is something that you'll find interesting when you go to university. Last but not least, let's look at this limit question. Well, we can write a simple recurrence relation by the following. And from there, assuming that there is a limit, then the limit must satisfy the following equation. Why? Because the limit of this number here is going to be x, and the limit of that is also going to be x. Well, let's try to solve this equation. What we will assume for the moment, we can show that there are only two solutions, which is 2 or 4. However, because this sequence is always going to be less than 2, and we'll see why in a second, then the limit must also be less than 2 or possibly equal to 2. And if we combine this fact with what we have here, we can deduce that x must be equal to 2. And perhaps it may be useful if we just plug the value into the calculator, so we work out what this limit happens to be. And as you will see, this value does indeed converge to 2. Now, I went through that rather quickly, but there was actually a lot of small details that may be worth discussing about here. The first is to talk about how do we know if the limit exists or not. And 2, we said that there were 2 solutions to this equation, but are there more than that? Pause and have a think. So, to establish a limit, we only need to have 2 facts. One, that our sequence is always less than 2, and secondly, that our sequence is increasing, which means that as you go through the sequence, the value is getting bigger. Let's see how we might show this. Well, for the first one, we can use induction. Why? Because if we assume that this is true, then x to the n plus 1, which is by definition root 2 to the power of x to the n, and by assumption xn is less than 2. Therefore, x to the n plus 1 is also less than 2, and so we are done. We can also show quite easily that our function is increasing by the definition. Now, why does this 2 facts establish the limit? Well, intuitively, we can draw the sequence and its value, and as n increases, we know that the function is increasing, but it's never equal to 2. So what you could imagine is that this function is getting closer and closer and closer to 2, and hence the limit is probably going to be 2. Finally, how do we know that there are exactly 2 solutions? To do this, we can establish this function here and see the number of roots. Well, when you differentiate this, we actually have 1 critical point. And so, now we know that there are roots at 2 and 4, and because there are 1 critical point, that must mean that there are no more than 2 solutions. Here's an interesting but challenging question on curve sketch. And we want to sketch the function y is equal to x to the power of x to the power of x infinitely. And for those who are pedantic, which are a very useful part of doing mathematics, is that what we are dealing with here is the limit of the function. Now, having these 2 representations of the function will be useful in, for example, finding the derivative, as well as finding the domain and the range. I will explain more on the next video. I will reiterate again that sketching this function is rather difficult, but it's also very interesting, because perhaps it will start extending your knowledge of A-level using your intuition. And we will talk more about this question properly on the next video. I apologize if I went through this rather quickly, or if there are certain things that you didn't quite understand. Such is the nature of using a video format for interview, when a real interview is about 2 persons having a dialogue together. That being said, I hope you enjoyed, and good luck with your interview.